Okay, last time we talked about how changing your longitude, so your position on the Earth in this direction, means the time of day should change because you're sort of crossing from the bright side of the Earth facing the Sun to the dark side facing away from the Sun. Now, by purely crunching the numbers, so like the full 360 degrees being a 24-hour day, we saw that 1 degree of longitude could be treated as a sort of time difference of about 4 minutes. We mentioned towards the end that time often is not handled in this way in real life. It's because it's just not that practical to have to change your clock a few minutes every time you travel 100 k's down a big road or something, right? So rather than just use degrees of longitude, people have made the decision to split the Earth into these bands called time zones. Okay, now a word of warning, in real life, it's not so perfectly geometrically split like that. They tend to respect things like borders of countries and territories and stuff, but the concept is the same. Okay, and we'll illustrate the concept here. The idea is that within a single time zone, the time is all the same. So the clocks in this green section are all set to show the same time. But the moment you cross from one time zone to the next one, there would be a single hour of difference. And it doesn't matter where you are or how far apart the 2 points are, if you travel across one time zone, there will always be 1 hour of time difference. Okay? And that just simplifies calculations a whole lot, as we'll soon see. As before, if we start from the Greenwich Meridian, that's like our origin, so that would be like a time zone of, say, 0, the one we start from. Then, just like last time, swinging to the east is treated as the positive direction, so your clock is going forward. So let's say it's, 12 p.m. in this time zone, then moving east like that, the time would be 1 p.m., 2 p.m., 3 p.m. You need to push your clock forward an hour for each time zone you jump across to the east. Because of that, we label these time zones as +1, +2, +3, and so on. Now, you might see different variations of this. Sometimes you'll see like GMT +1, +2, +3, standing for Greenwich Mean Time. But more commonly nowadays, you'll see UTC, and that stands for a Coordinated Universal Time. Okay, but really the important thing for us is the number that comes after it, with the plus, meaning the clock is going forward, and we are traveling east from the Greenwich Meridian. Likewise, if we swing to the west, we can treat this as something like a negative direction. Alright, our clock needs to rewind backward. So again, if it's 12 p.m. at the Greenwich Meridian at 0, then moving west, the time would go backwards, like 11 a.m., 10 a.m., 9 a.m., like that. Okay, you push your clock backward an hour for each time zone you jump to the west. And there are a few other subtleties, like what happens on the other side of the world and the date line and like half time zones and stuff, but that might be a conversation for another time, and you can sort out the particular details when you get there. This should be enough to get us going for now. So, let's say we're flying from Athens, which is at the +2 time zone, to New York, which is at the -5 time zone. We leave on Wednesday, 9 p.m. from Athens time for an 11-hour flight and want to sort of plan for what local time it will be when we are there. So what matters is these two time zones. And we can draw our familiar diagram where we've got Athens on the right, since it's at a positive time zone, and New York on the left with its negative time zone. In particular, Athens is at +2. New York is at -5. That tells us that the difference in time between these two places is 7 hours, which we will use in a moment. We leave on Wednesday at 9 p.m. in local Athens time, so we should put that date and time there. And what I like to do is pretend I'm wearing like an old school watch, right? Then I'd sort of work through the whole story first, before adjusting my watch at the very end to deal with that time zone difference. So I would just take the 11-hour flight now, which is just 1 hour short of 12 hours. So if I haven't adjusted my watch, that's just 1 hour short of it being 9 a.m. the next day. That would be 12 hours. We are 1 hour short, so my watch would be showing 8 a.m. on Thursday. And at this point, we're still working in Athens time, okay? But we need to now switch to New York time. How do we do that? Well, because New York is to the left on our timeline, we know we're going to have to rewind our watch back by 7 hours, that time difference between the two places. So if it's showing 8 a.m., rewinding it back 7 hours sends us to 1 a.m. Thursday. Okay, and that must be our final answer. So that's how I like to deal with these time zone problems. I just imagine working through the whole story and then fix my watch at the very end to account for the time zone difference. Okay, so that's all for this one. Thanks for watching. See you next time.